Here we go. I'm going to teach you logarithms real quick. Should be very quick. You're welcome to pause the video during any of the problems that we're doing. And you can do the problems before I do them. I'll try to explain them, but I'm going to go relatively quickly because this is quite a bit of review. So let's go ahead and start this up. Alright, logarithms. So we're going to be covering chapters 3.2 through 3.4. First off, exponential functions that are one-to-one, its inverse is a function, and that function is the logarithmic function. Okay, so we're talking about when we have 10 to the x, log base 10 is its inverse function. The function given by f of x equals log base a, where a is greater than 0 and a cannot equal 1, is called the logarithmic function with base a. Furthermore, the logarithmic function with base a is the inverse of the exponential function with base a, such that we have whatnot here. Okay? Now these two are very integral right there, so make sure you note that. Note that we have log base 2 of 8 equals 3. Remember that log base 2 of 2 to the third is going to be what this value is. It's 3. This one right here is the same kind of thing, but this is log base 1 over 4. Excuse me, log base 2. And that ends up equaling log of 2 of 2 to the negative second, which is, like we have up here, negative 2. This last one down here is actually a wrong answer. The book gave me a wrong answer. This is the same thing as log base 3 of 3, I believe, to the 4th or 5th. I think it's to the 5th. So we end up getting 5 as the correct answer for x, which equals x. Well, not really x. We're not doing x. But anyway, those are the explanations for those three. So the properties of logs are as follows. Log base a of 1 equals 0. Log base a of a is the same thing as a to the first, and so that is 1. Log base a of a to the x is equal to x, and log a raised to the log base a of x equals x. These cancel each other out in both directions. If they equal each other, log base a of x equals log base a of y, then x and y are equal to each other. Some basic properties. So look at these. If you want to try these on your own, you're welcome to. A good time to pause the video would be now. Alright, so the first one we have log base 5 of x and log base 5 of 8. We just said that if the bases are the same, then x equals 8. Same thing with this. We have log base a, or log base 5 of 1. If we go back up 1, log base a of 1 is always equal to 0. So x equals 0. So the graph of the log of the exponential function is the inverse. Okay? So if we have, let's go ahead and do 2 to the x. If we graph 2 to the x, we end up getting something as follows, where it goes like this, it crosses at 1, and then starts to exponentially gain after that. Now the inverse, if you don't remember, but you would like a little refresher, the inverse functions are always symmetrical with the y equals x graph. And so we can graph the other one. So this one had a point here. So log base 2 of x is going to look like this. Okay? So we're going to be talking about just the green. Green graph only. The green graph has a domain from 0 to infinity, but it does not include 0. It has a range of infinity to infinity. It goes to infinity. It goes to negative infinity. The x-intercept we see is right here. The x-intercept is 1, 0. The y-intercept, it doesn't cross the y-axis at all, so we end up having a y-axis as the vertical asymptote. Doesn't cross that vertical asymptote, so we have a vertical asymptote right here. And lastly, it is increasing on the entire interval, so it's increasing on this interval. From a is greater than 1. Alright, so we talked about some shifts here, and with the class I just said to them, I said these shifts in the transformations are all similar to what we've seen. So, if we have log base 10 of x, this is a shift left 2 units. This right here is a shift left 2 units, and it's shifted down 1 unit. Okay, so for b, we end up getting something that looks like this. So that's the b. And for c, we get something that looks a little bit more lower, which is starting from down here. Oop, don't do that right there. Going like that. So that's shifted. Okay? Now, it doesn't cross this little x-axis right here, but don't think that that's an asymptote. There is an asymptote, however, right here. Okay? The asymptote is where it can't cross, and it tells you by the shift. Okay? If shift left and right, it changes the asymptote. It moves it over. So this vertical asymptote is now x equals -2, rather than x equals 0 on this one. Okay? So make sure you remember that kind of stuff. And we have a vertical stretch and shrink if you add a little value over here. There's a vertical stretch and shrink. But we're not going to get too much into transformations. We might graph a few of these, but that's about it. Natural log. So we want to state that the logarithms function with the base e is called a natural logarithm function and is denoted by f of x equals ln of x. What is it saying? It's saying this is equal to log base e of x. But instead of writing log base e, we write natural log because that's the natural function of it. What does that mean? Well, that means ln of x is the same thing, and all the properties of log base e of x are the same. Okay? So we end up evaluating what happens when we have log base e of e to the 5th power. We end up getting 5 because they cancel each other out. So ln of e does the same thing. Vice versa, they're going to cancel each other out, and you end up getting 3. And for this one right here, we get ln of e to the -2nd. We end up just getting -2. So that's how natural logs work. They have the same properties as logarithms. Once again, ln of 1 equals 0. And anything below that doesn't exist. So the change of base formula is a way for you to calculate values.
Vicki Mueller, please call the front office. Vicki, please dial 0.
Is to calculate values of any log-based function, because some calculators don't do that. There is a function on some calculators that say you can do it, but I want to make sure that you know how to evaluate any logarithm or natural log anyway. So we have log base a to the x. That equals log base b, so any number you want to the x over log base b to the a. So a goes on the bottom, x goes on the top, and we can choose b. Let's choose it as 10, because on your calculator, log function is always log base 10. Okay, on your calculator. This one also shows up on your calculator, so these two do. And you're welcome to use those as well, but I'm pretty sure you've done this already. So for instance, we have this. If you want to do this on your own, you might as well pause the video now. Okay, I'm going to go ahead and do it. This is log base 10 of 30 over log base 10 of 4. And we can go ahead and rewrite that in terms of or natural logs as well. ln of 30 over ln of 4. And what we find is both of those end up equaling 2.453. Okay? I could give you a bunch of other ones or whatever, but I think we can probably figure that out. The properties of logarithms and natural logs. Okay, these properties are important. I'm going to talk about them individually. Log base A of u times v. Now this is any two numbers multiplied together. You can separate them out with a addition. Same with natural log, you separate it out with addition. Dividing, you separate it with a subtraction. And dividing, we separate with subtraction as well with natural logs. And lastly, if we have two bases that aren't the same and one's raised to an exponent, we can take that exponent and put it in front as it is right here. Same thing goes with ln. We can move that right over. Okay, so division means subtraction, multiplication means addition. Same with this. So, examples. You might as well pause it if you would like to do this on your own. I'm going to be doing this in just a second. Alright, so the first one we can separate it out as ln of 2 minus ln of 27. And you put that into your calculator and you get roughly negative 2.603 as the value. Okay? For number 2, same thing, kind of. Now this one says simplify. So when I say solve or evaluate, we'll go ahead and give some numbers, and I'll make sure to say round to the nearest 3 decimal places or whatnot. Simplify. That's spelled wrong. There we go. So we end up getting this. Now this can be changed to negative ln of 2 to the negative first. But we have that property that says this can go into the front, so it turns out that this is the same thing as ln of 2. Put a box around your answer, and you're done. I'm sick of this color. Let's go with purple. Alright, so expand. Use the properties that we know now, because we have basically said all the properties, and expand it out. Well, what do we end up getting? We get log base 10 of 5, and let me move this around, log base 10 of 5 plus, and this is how one of the students did it in my class today, base 10 of x to the third plus log base 10 of y. But this actually, these two bases are different, so we can move that 3 right out in front. Okay, right out in front. So we have log base 10 of 5 plus 3 log base 10 of x plus log base 10 of y, and that is fully expanded. Put a box around it, and you're good. This one, let's expand it. We have ln of the square root of 3x minus 5 minus ln of 7. So we want to make sure that we actually simplify this as well, so we need to do ln. Now this is to the 1/2, okay? This is to the 1/2. Let me go ahead and erase it, and I'll put this to the 1/2. So we end up getting 1/2 ln, and we can't do anything with this, so we just leave it as 3x minus 5 minus ln of 7. Okay? So I'm going to ask you two things to do, one to expand and one to condense. So let's condense this one. This one turns into log base 10, and 1/2 would move up to this. But the 1/2 of x is the same thing as the square root of x, plus log base 10 of x plus 1 to the third. And this can condense more because addition means we multiply those. So we get log base 10, and I'm going to go ahead and put brackets here. square root of x times x plus 1 cubed. And one more bracket. Try that again. And that's as condensed as it's going to get. Same thing with this one. We end up getting ln of x plus 2 squared minus ln of x. So we want to condense those more because this is subtraction, so we can divide. ln of x plus 2 squared divided by x. And that's as condensed as it's going to get. So expanding, condensing. Alright, so let's solve a few more, and I just wanted to note that sometimes we can use logarithms to solve things, and sometimes we can actually just see that these two are going to be the same. Okay, for this one, 2 to the x, we get equals to 32. We can actually change this to 2 to the x equals 2 to the 5th, and then solve for x. So note that you could log base 2 both sides of the equation, and you would get the same answer. Okay? These ways are equivalent. Okay? Either one you can do. So, you're welcome to try these. I will do them right now. So, these ones we can actually solve. Okay? We can get some sort of solved answer. We don't need to do any decimal points. So, let's just solve and simplify. Solve in simplest form. So I can see that I can add ln of 3 to both sides. And we end up getting ln of x equals ln of 3. Well, we have a thing that states if they have the same base, then they equal each other. So x equals 3. The next one over here, the next one states that if I have this, I can also use the property of exponents. So that ends up equaling 3 to the negative x. And I want to change this to something base 3. Well, that's going to be 3 base 2, or 3 squared, excuse me. And so now, because the bases are equal, the tops can be set equal. Negative x equals 2, so x equals negative 2. Alright. Next one. We can ln both sides to get rid of the e. So we can do ln of e to the x equals, but if we do it on one side, we have to do it on the other side. ln of 7. This ln cancels the e and brings down the x. So we have x equals to ln of 7, and let's go ahead and just leave it like that. We don't have to evaluate that. Alright, the next one. Next one, same thing, but we can raise it to the eth power. E to the ln of x equals e to the negative 3. Now, these are going to cancel each other out. We end up getting x equals e to the negative 3rd, but the negative exponent isn't considered all the way simplified, so we end up getting x equals 1 over e to the 3rd. That would be the most simplified version. And lastly, we raise this to the 10th power, because that's log base 10. So we do 10 log base 10 of x equals 10 to the 1st. So these cancel each other out. I had this as negative 1 on the other one. And we end up getting x equals 10. Alright? A couple more. These are to 3 decimal places. Then we have one more difficult problem, and then we're done. So, divide by 3 on both of these. We end up getting 2x equals 14. We're going to now take the log base 2 of each one of those. So, log base 2 of 2 to the x equals log base 2 of 14. These cancel out, and we end up getting x equals to log base 2 of 14. But we have to do a change of base formula. Log base 10 of 14 now over log base 10 of 2. And when we do that, we get a nice number. I don't have it written down, but I do have it written down. It is about 3.807. Okay? This next one down here, same thing goes. We divide by 4. Divide both sides by 4. We end up getting e to the 2x equal to 5/4. So I'm going to ln both sides. We get 2x equals ln of 5/4. And then I'm going to divide by 2 or multiply by 1/2. Dividing by 2 seems a little bit cumbersome. So after we do the ln of 5/4, we take half of it. These cancel, and we get a value of x equaling to 0.112. Now, Austin, in class today, he wrote ln of 4e to the 2x equals ln of 5. And actually, this works out if you remember the exponent laws. So ln, these are multiplied together to ln of 4 plus ln of e to the 2x. Well, that just equals to 2x. We subtract ln of 4, and we get 2x equals ln of 5 minus ln of 4. And then we divide by 2, and we get x equals the ln of 5 minus ln of 4 over 2. And if you look, if you remember the properties, ln of 5 right here, I don't know if you can see my pen very well, but where's that little laser pointer? Oh, there we go. Ln of 5 over 4 actually is the same thing as ln of 5 minus 4. Okay? So those are two things that you could do. Oh, crud. I don't know how to get out of this. Escape. Okay. Good job. Last one we solve, you want to try this one on your own, is a quadratic. So you need to make sure that you use the quadratic properly. Now, some people may think it's comfortable to plug in x for e to the x. I'm going to go ahead and just go e to the x squared minus 3 e to the x plus 2 equals 0. I'm doing this because I am trying to get it into quadratic form. Now, if you are comfortable with adding this as an x, so you have x squared minus 3x plus 2, and that's comfortable for you for factoring, then whatever floats your boat. E to the x, what two numbers multiply together to be positive 2 and add together to be negative 3? That's going to be negative 2 and negative 1. So same thing over here, x minus 2, x minus 1, and then you're welcome to substitute that back in right here. And you end up getting that. So we have to set each of these individually to 0. E to the x minus 2 equals 0, and e to the x minus 1 equals to 0. So we get e to the x equals 2. We're going to ln both sides. We're going to be getting x equals ln of 2 as one solution. And the other solution, we're going to do e to the x equals 1, ln both of those, x equals the ln of 1, which equals 0. All right, so your homework tonight. I cut it down quite a bit. There's only 23 questions. It should go very quickly. Don't spend too much time on it. If you're spending too much time on it, skip it and come back to it on Monday in class. Okay? That's the end of the video. Enjoy.